This is Algebra 1, Lesson 7.1, Solving Linear Systems by Using Graphing. It's also known as the graph and check method. More often than not, it's just used as a quick representation once we learn the substitution and elimination methods, which will come next. But it is a way to graph to determine solutions of a system, beginning on page 398. The first thing we have is a couple of definitions. First one says a system of linear equations. It's two or more linear equations in the same variables form a system of linear equations, or a linear system is just another word for it. So a system, just two or more, everybody. We know how to graph an equation on one plane. Now we're just graphing two on the same plane. The second definition is the solution to a system. Most, and we'll cover the exceptions after, but most systems will have one solution. When you graph two equations on one plane, every point that falls on the red line, when you plug it in algebraically, is going to make a true statement. Remember, solutions are true statements. You're going to get an equation that's true. Every point on the blue line is going to be true for the blue line. But remember, the only point that they have in common is their intersection. The only point that'll be true for a solution, or in order to make the solution to the system, is going to be the one point where they cross, the intersection. Today we're identifying that intersection. Here are your steps for solving a linear system using graph and check. To use the graph and check method to solve a system of linear equations in two variables, use the following steps. Step 1, write each equation in a form that is easy to graph. We have learned several different methods to graph. The first way we learned, the very first way, was to plug in points like -2, -1, 0, 1, and 2. And then get a y value and to just plot each point and then connect the dots. That was the first way we learned. Then we learned a faster way using mx plus b. Then we learned two additional methods after that are not as fast but have their place as well, with point slope form and standard form. Notice it says to put it in a form that is easy to graph. It doesn't tell you which way to graph it. We've given you options in here that you can use to graph. So whatever way is easiest for you is the way you should use. Okay. Now for most of us, that'll be in mx plus b form. So that's the way we're going to go through it today. But if you don't like using that method, if you feel more comfortable with another method, notice it just says make it easy for yourself to graph. Step number 2 is to graph both equations in the same coordinate plane. So graph them both on the same plane. Step 3 is to estimate the coordinates of the point of intersection. When I looked at all of these really quick before we're going over this, they all go through at integer points, which means if it is really close to what we consider whole numbers, that's the numbers you're going to use. It's not going to be halves and thirds and partial numbers and stuff like that. Even though that will happen anytime you try to come up with your own example, that'll happen more often than not. But estimate where they intersect. What is the x and y value? And in step 4 is to check algebraically by substituting or plugging it in and then seeing if you get two true statements. So graph both of, make sure you can graph both lines. Graph them both on the same plane. Determine what is the xy value for it. Once you graph them on the same plane, determine which one's the xy value, and then plug it back in and see if it's true or not. Here's example number 1. And again, it's at the top of your page is where you should be graphing, and I had to fit it up there. Solve the linear system graphically. Check the solution algebraically. Again, once we get past this method, I'm going to show you a much faster, more reliable method. But you have to understand this one first to make the other one make sense. 5x plus 4y is equal to -12. 3x minus 4y is equal to negative 20. So what you're saying is what times x plus 4, I'm sorry, 5 times what plus 4 times what equals negative 12, and the same thing with the other equation. But we have to use the same values to make both of them true. So write each equation in a form that's easy to graph, such as slope-intercept form, y equals mx plus b. Let's look at equation number 1. First thing you want to do is move 5x over. When you move it over, notice on the right side it becomes negative 5x. Then you want to divide by 4 to get y by itself. That gives you negative 5 over 4. And then negative 12 divided by 4 is 3. So here is your slope-intercept form right here. Y equals mx plus b. Almost all of us can graph that with no problem. Mx plus b. Then underneath it, it identifies the slope and the y-intercept for you. We could do the same thing with equation number 2. Move the 3x over. When it goes over, it becomes negative 3x. Then divide by negative 4. A negative divided by negative when you do the other side is going to give you 3 over 4x plus 5. Again, almost all of us can graph that with no problem. Y equals mx plus b. We know to begin at b and to move up 3 and to the right 4. So there's your slope and your y-intercept. So you have two equations that you are capable of graphing now. They are easy to graph. That was step number 1. Step number 2 is to graph both of them in the same point. I'm going to make this one the blue line. Now, make sure when you graph these equations, you are drawing straight lines and you're trying to be as exact as possible. This is why you need to use graph paper. This is the first lesson that you actually need graphing paper for, to where you don't make mistakes. This first equation, we know where to begin. You begin at negative 3. So on your y-axis, we're going to begin at that point right there. And again, I'm making these points small because I want you to go through that exact spot. Don't make it really big and then wind up passing through at the bottom like that. Try to make it through the exact spot. We know based on our b value, we're going to go down 5 and to the right 4. So from that point, we're going down 1, 2, 3, 4, 5, and to the right 1, 2, 3, 4. There's our second point. So we have 2 points. We can draw a perfectly straight line through there. Again, this is one of the tougher parts, drawing the straight line to make sure you're in the right spot. So as straight as you can, draw your line. Now, look, I'm manipulating this straight line right here. If I go through the point right there, look where it is. If I move it just a little bit down, look how much it moves. So try to be as straight as you can to where we can see where it's going to intersect with the other line. The other line, I'm going to make it in red. Y equals mx plus b. We know to begin on that one at 5. So begin at that point there. I'm at this point. I know I'm drawing it real small, but that's where I'm crossing through right there. 3 over 4, our slope, tells us to go up 3 and to the right 4. So go up 1, 2, 3, and to the right 1, 2, 3, 4 at that point right there. Again, I'm at that point right there. And then again, draw a straight line, as straight as you can make it, to where you can see the intersection. And I keep stressing this as straight as you can make it part, because that's why this is the least effective method when it comes to solving systems. Because we have to estimate on our step 3 what that intersection is. Now you should, if you were perfectly straight, you should be able to estimate, and I was as straight as you can be. And look, I'm not even on a perfect intersection. But we can estimate that point, and that's what step 3 is. It says to estimate, and that's what it says on right above example number 1, that they pass through at negative 4, 2. Negative 4, 2. That's where you should have them crossing through. Step number 4, this is called the graph and check method. So the last step is you want to check -4, 2 as a solution. Substitute -4 for x and 2 for y into each original equation and make sure you get true statements. So when we plug it into state the first equation, 5x plus 4y equals -12. 5 times -4, we know we get -20. 4 times 2, we know we get 8. -20 plus 8 is -12. That's a true statement right here. That's true. We know that's true. The same thing's true with the other one. When you plug in that same value, -4, 2, in place of x, 3 times -4 is -12. In place of y, -4 times 2 is -8. -12 minus 8 is -20. Again, a true statement for both of them. So because 4,2 is a solution of each equation, then it is, I'm sorry, -4,2, then -4,2 is a solution of the system. So we name the intersection by graphing both lines as straight as possible. Okay, take 2 minutes and do number 1 on the checkpoint on the back. Go back to your steps if you have issues. Get them into forms that you can graph easily. Graph both of them, estimate where they intersect, and then check it algebraically. Okay, let's take a look at this one. Just got told that the graphs I put on there might have been a little bit too small to see the intersection. Let's see where we made a mistake or where I made a mistake when I made the sheet. Let's go through the steps regardless. Make sure you can go through the steps. Move this first equation into a form that we can graph. So if you move 3x over, you're going to have -4y on the left by itself. You're going to have -3x on the right and +4 on the right. So -4y equals -3x plus 4. Divide by -4 to get y by itself. So you're going to have y equals a negative divided by negative is going to be a +3 over 4x, and a positive divided by negative is a -1. So we can graph that equation. We know to begin at -1. We know we have to go up 3 and to the right 4. So 1, 2, 3, and to the right 4. There's our second point. With 2 points, we can draw ourselves a straight line. And again, I know my graph it goes farther than you guys. So before you draw your straight lines, it might help to see where you think it's going to intersect. Watch what I mean by that. Before I draw my straight line, I'm going to go ahead and put my points for the second equation. This one. 2y, if I move the x over, it becomes negative x. Positive 8 is already there. Divide by 2. Y equals, that's negative 1 divided by 2x, and 8 divided by 2 is plus 4. We can graph that equation as well. There's 2 versions of equations that we're comfortable graphing. Begin at 4, go down 1 into the right 2, down 1 into the right 2. So you can see where they're going to intersect. You can see they're going to intersect in this area right here somewhere. So what I mean by that is I don't have to include my lines going this direction nor this direction, because that's not where the intersection is going to happen. That helps me with this program I'm running, do straight lines as well as I can. So if I do the red equation first, I know I need to begin right here, and I need to go this direction. The same thing if I do the blue one next. And again, it's not necessary to use 2 different colors. It just helps with the explanation up here. You can see where the intersection takes place. You can estimate it. So step 1 was to get it into forms that you can graph easily. Step 2 is to graph them both on the same plane. Step 3 is to estimate what is this point right here. To me, that point looks like its x value is 4 and its y value is 2. So x is 4, y is 2. That's step 3. Step 4 is to check them graphically. So check them algebraically. So algebraically plug in 4, 2. 3 times 4, this is just like the bell work, minus 4 times 2 equals 4. 3 times 4 we know is 12. Negative 4 times 2 is minus 8. And 12 minus 8 is equal to 4. That's a true statement. The same thing's true with the other one. Let's see if x and y work. Instead of x, we're plugging in 4. Plus 2 times y, instead of y, we're plugging in 2 equals 8. 4 plus 2 times 2 is plus 4 equals 8. Again, 4 plus 4 is equal to 8. So your solution to the system of the inequalities is this, 4, 2. That is the solution, 4, 2.